Hi, today we're going to be looking at the 2015 PAT paper and going through question 17. So question 17 says that there is a boat floating on water and it encounters some waves of the form y of x and t equals a sine of kx minus omega t. It tells us that these waves have wavelength of lambda equals 10 meters, amplitude of 0.5 meters, and a velocity of 2 meters per second. And we're asked to find the maximum velocity of this ship. So let's think about what this y of x and t means. So if we imagine we drew a axis here and labelled it x and y. So we're thinking about the motion of this wave with respect to some coordinate x in this direction and y in this direction. So the y of x and t denotes the vertical displacement of this wave. And it will in fact go below the axis as well as it goes negative. So perhaps it's best to shift the origin of our wave, our axes up. So now I can go below the axis as well as the sign goes negative. So we're trying to find the maximum velocity that this ship moves. And we know that velocity is the derivative of displacement. So we know the velocity of this ship. So we'll say velocity of ship, and we'll call that v sub s, is the time derivative of the displacement, which is in this case y of x and t. But what's confusing here is, in fact, our function of displacement is a function of horizontal displacement and time, and we can't differentiate it if it's got both variables in there. So what you have to notice is the fact that this boat isn't actually moving in the x direction. It's simply floating up and down. As this wave comes along and passes over the boat, it's going to bob up and down vertically, but won't move left or right. So in fact, we can think of x as just being a constant, because this boat won't be moving along, it'll only be shifting up and down. So we can in fact differentiate this equation with respect to time, because our x is, in some respects, in this case, a constant. So let's do that. So d by dt, our time derivative of our function of y of x of t, or sine of kx minus omega t. So we know the derivative of sine is cos, but we want, by the chain rule, to multiply that by the derivative of the inside bit. Well, d by dt of kx minus omega t, kx is a constant, because we're thinking of x as a constant, and that goes to 0. So it's derivative of minus omega t goes to 1, so we just get minus omega. So what we end up with is minus omega times a, and the sine goes to a cosine of kx minus omega t. Now let's try and find the values of some of our constants. Well, we know that we have the equation c, the wave velocity, or we've written it as v here, so let's write it as v. So v equals f, our frequency, times lambda, the wavelength, which tells us that our frequency is equal to v over lambda. Well, we have our v and we have our lambda, so we can write this down here. So we get the frequency of the wave, the waves that are hitting the boat, is equal to our velocity 2 meters per second over our wavelength lambda, which is 10, which tells us that this is equal to 0.2 hertz. Now, we also know that omega, our angular frequency, is equal to 2 pi f. We see omega is actually present in our equation here. So we can find omega. So that's equal to, well, omega equals 2 pi and times our frequency, which is found 0.2, which is equal to 0.4 pi radians per second. Now, why do we want omega? Well, we see omega is in fact in front of our time derivative, our velocity equation. So we need it to calculate the maximum velocity. Now we just need to find our value of a. Well, we've actually been given that. So if we imagine our wave is moving along this graph, we've been told the amplitude of this wave is 0.5 meters. So that means that the maximum point is going to be at 0.5 meters. And, well, we know it's a sine equation, and we're told the equation's of this form. So that must mean that A is 0.5 meters, because the maximum value sine can take is 1. So when the maximum value of sine is 1, we want this whole thing to equal 0.5, which tells us that A must be 0.5. 0.5 times 1 gives you 0.5. So we know that A equals 0.5. Now we simply want to think, when is our velocity equation going to be a maximum? Well, omega and A are constants. The only thing that varies is our cosine expression. And the maximum value cosine can take is 1. So this will be a maximum when our cosine value is 1. So we're simply left with omega times A. So that tells us that our maximum velocity, which we will call, we've written it as Vs. So we'll write that as V max. So let's write our velocity V max is going to be equal to, well, simply omega times A, which we know is 0.4 pi times 0.5, which equals to 0.2 pi meters per second. And, well, for approximation purposes, if we say pi is around 3, we can approximate this as 0.6 meters per second. And that'll be our maximum velocity which with the ship will move.